So now I would like to invite Dr. Jacques, who is undertaking research on developing an educational game, which is called In the Shoes of Algorithm, which will be very much connected with the practical approaches to what Professor Cotillaine proposed for the multiliteracy in the algorithm-driven social media and AI. So please welcome Dr. Jacques.
So good afternoon, everyone, and I will start by saying that I'm really happy to be here in front of you, and as we say in French, merci beaucoup. So thank you very much to Professor Hanson Young for the invitation, also the Community Media Foundation and the Gyeongin National University of Education. So it's really a great opportunity for me to be here. I'm working in Belgium, the University of Namur, a small town in the south part and French-speaking part of Belgium. My research center is the Research Center in Information Law and Society. And you can also see the logo of our partners here, which is a media education organization, which is called Action Média Jeunes. So, just to be clear, my background is communication and information science, and since the beginning of my career, I have a strong interest in media education and media literacy. So, I'm here to talk to you about this project, which is called Dans la peau d'un algorithme in French, which should be translated literally in the skin of an algorithm, but in English we should say in the shoes of an algorithm. So I'm sorry, you can see our website, it's still in progress. I will soon translate it in English, and why not in Korean, I hope so. But so you can also, in a few weeks, you will be able to find all the information about this project in English. So at the beginning of this project, we as a team working on this project, we share concerns and questions about the growing place of algorithm and on the digital media, website, platforms, and application. We wanted to understand the effect they might have on us individually, in our daily lives, on our social relation, tastes, habits, but also their effect on us collectively, on our societies, institutions, power relation. And as all the team we were invested in media education, we really wanted to help teenagers to understand algorithm, how they are used now in digital media. So we wanted to empower teenagers growing in a society where algorithm play an important role. So to be clear, our main goal was not to transform teenagers into computer scientists or programmers, but rather to give them a basic understanding and a basic experience of algorithm and some key issue related to them. So I'll go quickly this is the Belgian team. So just to stress out the fact that it's a partnership between University of Namur, 3 researchers, and also these 2 media educators from this Belgian organization, which is called Action Média Jeunes, which try to educate youngsters to media, also based in Namur, Belgium. So, what is an algorithm? When you go on the internet, algorithms are everywhere, and especially recommendation algorithm, which recommends you content you might be interested in. Algorithm is also a bit of a buzzword in Belgium. Algorithms are frequently mentioned in the news or in the political agenda, often in a very simplistic manner. But at the beginning of the project, we had the impression that for many people, the concept of algorithm was really difficult to understand. I don't know what's the situation here in Korea, but in Belgium, mathematical literacy or digital literacy, computer programming are skills which are developed only by the students who decide to go deeply in these domains. So for many people, don't learn about that in the schools, and it's a bit the same for teachers, which are not yet trained in Belgium to teach on those topics. It was also a challenge for us at the beginning because we were working in the social sciences, and we had also to do the job and try to understand what algorithms are. So, in fact, it's quite possible to find an easy definition of an algorithm. On the slide, you can see a definition proposed by my colleagues. Yeah, an algorithm is a stabilized and formalized procedure for manipulating discrete data. Algorithms are computational techniques used by scientists and engineers. So when they find a computational technique useful, they can decide to stabilize it and formalize it, making it an algorithm. A recommendation task seeks to foster interaction between users and items. And nowadays, recommendation algorithms largely support interaction with media and digital content. And various hopes and fears are associated with recommendation algorithms. Hopes that they might assist us in selecting items that might best suit what we need, and also a lot of fears that they can be used to manipulate people to consume or to find some contents. So these hopes and fears stand in fact on a common ground which rests on the difficulty to know and understand what data and algorithms are. So, as I told you, our background is mainly media education and media literacy approach. The media education perspective encounters this need to educate to algorithm, and in our case, to algorithm supporting media's recommendation. So we work with this definition of media literacy, which is a set of competencies needed to be critical, creative, autonomous, and socialized in a contemporary media environment. But we also enrich this approach with other contributions from the digital and technological literacy field of study, which is more focused on skills related to the use, understanding, and evaluation of digital technology. We wanted to bridge media literacy and technical literacy to evaluate, to educate critical citizens, and we found great inspiration in the field of critical technology education, which is a way to discuss technology roles in societies and in people's everyday lives. So the aims of critical technology education is to reflect upon technology and to try to see how it might be possible to change the way things are. The idea is to learn how to consider technology differently. We also looked at the literature from two other fields, the history of philosophy of science and the science and technology studies perspective. We found great insights about how it's possible to explain technology. For Keller, an explanation is simply defined as a description of a phenomenon, and to explain technology, the concept of scheme seems to be particularly useful, as the schemes describes the part composing the technical object and gives an account as their operation in the working of technical object. In an educational perspective, the schemes constitute a privileged entry point of technical object within culture, as Simondon said. It gives the keys to allow people to understand technology in the direction of a citizen-oriented education. As the explanation of technical objects, the schemes can lead to consider technology differently. According to Keller, an explanation works if it meets the need of an individual community. But how is it possible to meet these needs in our societies? What are these needs and how these needs are expressed? So we ended up, after this literature review, we ended up with this research question. What should be the core concerns of media education initiatives focused on digital media relying on recommendation algorithms? We first wanted to explore the issue and challenge raised by recommendation algorithm and then develop an educational intervention activity. So, and what we also wanted to do is to explore this question from the point of view of users. And that's why we decided to anchor our answer in actual representation users have about algorithms, the problems they might encounter, the question they have, this is why we developed a game which was first used as a focus group technique. I will tell you more about that in a few slides. So let's turn to the method we use now. So we launched a design-based approach, which implies the creation of an educational intervention, the test of this intervention with learners, and then the analysis of collected data to improve the intervention and then to formulate or to create theory. On this slide, you can see the steps of this project. So first, we designed the game in the shoes of an algorithm, a game which confronts individuals with a simplified version of a recommendation algorithm. Second, we used this game as a focus group technique to identify key challenges for media education intervention focused on algorithm. I will present the result of this phase at the end of this presentation. The third step is improving the game and implementing it as an educational program. Then we want to evaluate its effect and also to be in a continuous improvement logic. And finally, and this is also why I'm here, we want to adapt this game to other countries and context and to conduct, if possible, a comparative analysis. So for this exploratory phase, we conducted 4 game sessions with teenagers engaged in secondary schools. What we also we also conducted interviews with 2 media educators who were in charge of the game sessions. And finally, we also organized 2 game sessions with adults and researchers. The idea here was to test our approach on a different public and to, with a higher level of expertise, to enrich our analysis and to check if all important issues were covered. So let's move to the game now. So I'll now explain the core principles of this game. So the goal of the game, if you have the chance to play to it, is to recommend music videos from YouTube to 2 different teenagers, Janelle and Nicola. So to do so, participants receive datasets about music videos and viewers. They also receive short descriptions of Janelle and Nicola, who were inspired by actual teenagers we know. It's a pen and paper game. There's no need of computer or calculator, even if they might be used to help for the calculations. And from our point of view, in Belgium, but it's maybe different here, this game is adapted to teenagers of 14 years old and older, and a game session lasts on average 2 hours. So in the first phase of the game, the participants are regrouped in 3 teams. And each team will receive different type of data sets, and on the basis of these data sets, they have to formalize a calculation and, in fact, create an algorithm to attribute a score to each video. Scores which allow them to classify the videos in order to be able to recommend them to Janelle and Nicola. So the team A, here you can see, receive data about the music video, for example, the release date, the number of views, like, dislike. Team B receives historical data about users that have viewed videos similar to Janelle and Nicola. And finally, Team C receives datasets about the viewers of the video, the gender balance, age balance, and origins of the viewers. So each team has to process its datasets with a calculation in order to produce a ranking of the music video to recommend to Janelle and Nicolas. And after that, in the second phase, the 3 teams gather and they have to compare their rankings. Each team describes the dataset they received to the others and how they proceeded to create an algorithm. The 3 teams have then to work together to produce 2 final rankings, one for Janelle and one for Nicola. So they have to weight and balance and calculate a final recommendation list. In the phase 3, the final recommendation list is compared to what Nicola and Janelle actually declared to like, and the order they decided to watch the videos. This phase is in fact a kind of opener for the final phase, which is a discussion. So the final phase is an open discussion, moderated by the animators, where participants discuss their experience of the game and of recommendation algorithm in general. So for the exploratory phase of this research, this phase was semi-structured. Media educators were raising some general questions with the participants. For example, they asked about difficulties experienced during the games, or what were the objectives followed by the teams when creating their algorithm. For the third step of the research, where the game is not only used as a focus group technique, but as a real education activity, this final discussion is structured and led by the media educator around some of the key challenges we identified at the beginning of the project and which I'm going to present to you now. So, if we move to the results of this exploratory phase of this project, we analyzed the recording of the game sessions to identify key challenges for media education, and more specifically, we analyzed the difficulties, questions, and debates raised by the participants during the game sessions, the reflection they shared during the final discussion. From there, we produced a list of themes which appeared during the game sessions, and as a final step, we organized this list of themes and issue around 3 axes that will be the core structure of our results. So, I'll just let you read this extract. So, the first axis we propose is related to data and computation issues. So, we find that this excerpt is a good illustration of this axis. We have one student explaining how they proceeded with these teams to produce a ranking of music videos. As you can see, they were quite good at math, and this example shows a great capacity to articulate choices they made and articulation and calculation they had to do to implement those choices. But of course, it was not the case and that easy for everyone. So actually, the first axis we propose is related. So actually, we found that many discussions, debates, and difficulty of the participants were related to data and computation, which is our first axis. So participants had, on the one hand, difficulty to interpret data sets, asking, for example, what was the meaning and the potential use of data about the origin of few words was, questioning its value in regards of other dimensions, like languages or cultural traits. On the other hand, they had also difficulties to handle data sets. For example, asking themselves how to transform some data set they received in order form to be able to calculate them. Another set of difficulties were related to the capacity to formalize, execute, and understand abstract calculation rules which can be applied to different data sets. Difficulty to formulate abstract calculation rules, difficulty to create computable and manageable calculation, difficulty to anticipate the results of a calculation. So we find this an interesting axis for media education to work on, and also a potential learning outcome of the game, which is to fragilize the idea that algorithms are pure objective and mathematical entities. It shows to participants that algorithm implies mathematical choices made by humans and related to their interpretation of numbers, their capacity to understand calculation and to formalize it. So we think media education related to recommendation algorithms should work on this axis focused on data and computation, highlighting the relation between the mathematical dimension and the fact that mathematics are used by humans that have to define and implement these calculations. So the second axis we propose is focused on the notion of taste. As you can read, taste appeared as something difficult to understand and to define for some of the teenagers. In fact, we saw during the game session that many discussions and debates were about the meaning of tastes, which are difficult to define and explicit. For example, students debated a lot about the fact that tastes are not always logical, that someone loving a song from an artist will not necessarily love all the songs from the same artist. Some participants also pointed out the fact that tastes are evolving over time. Yeah, most of those discussions were anchored in personal experience about their own taste or the taste of their relations. Some a priori and cliché were also frequently mentioned about the public of a particular music style or an artist. This shows a need for a complex and nuanced approach of tastes, which recognize that there are dynamical constructs which emerge from interaction between humans and their environments, which are constantly evolving. This is the second axis we propose for media education about recommendation algorithm, and also a potential benefit of this game, which brings a series of questions regarding this issue, and which fragilize the idea that algorithms are totally able to deal with the complexity of human tastes. So the third axis we propose is at the crossing of the first one and focused on recommendation algorithm. So we have three levels here. The first one is the micro level my algorithm. Under this label, we regroup discussions, debate, problems which were related to the algorithm created by the participant during the game sessions. When they had to imagine a formalized calculation about taste, many discussions and debates appeared about which criteria to use and about the importance in the process. We also observed discussions about norms and values related to the creation of a recommendation algorithm and the objective of this design process. There were also many discussions about the characteristics of the public targeted by the recommendation. On a meso level, we noticed many discussions about YouTube and its algorithm. The objective of this company, the fact that they are motivated by benefits, that to do so they have to generate desire and capture attention of viewers. Participants also debated about the difficulty to understand the YouTube algorithm, also debating about its limits and dysfunction. And another issue raised by participants was the fact that this algorithm is favorizing big players instead of favorizing a diversity and small creators. Finally, on a macro level, we group discussions on the nature and function of recommendation in general, which appeared in the final discussion on the basis of questions raised by educators in charge of the game. This led to debates about the degree of freedom toward algorithm and the choice users can make to follow or not these recommendations. There also were discussions about the benefits of recommendation in an information abundant digital world and the way they can ease the navigation on the internet. We also noticed participants had trouble to connect their experience of YouTube and the game to alternative or older form of recommendation. So we synthesize this third axis with the idea that on the one hand, recommendation algorithm has to be understood as a social constructions created by individual and organizations motivated by norms, values, and objectives. And on the other hand, that recommendation algorithms are social constructors because they have the power to partially shape the audience taste, the consumption of cultural goods, and to give advantageous position to some creators company by adopting a particular logic, which is of course not neutral. I also want to highlight other key points for media education about this game. First, people who have weakness in mathematics may have difficulty at the beginning of the game sessions, so there is a kind of entry cost, but with proper help, we think that it can be overcome. Second, the game, of course, youngsters know already some things about algorithm. It's not a total discovery for youngsters, and so educators may start from that and then try to help teenagers to construct a more deeper understanding and a kind of big picture of algorithm and the challenges they raised. I think it's connected to what you said about the parents, but also here youngsters tend to focus on economical problems, leaving out other problems, such as cultural and political concerns, for example. And finally, it's also necessary to have help teenagers to have an informed opinion, which go beyond the simplistic, it's good or it's bad, and to give them words and also help them to think to alternatives. To recommendation or calculation. So I'd like to turn to the future and also the present now. So this project started in Belgium, but we met with some of the Korean teams, with Amy and Han Song-yeon. We met last year at the Media Education Summit in Hong Kong, and we wanted to collaborate. And so we are joined by a great team here of Korean researchers, practitioners, and we want to work together to further develop this game and making it an international project. So The future. The game actually is being adapted to the South Korean context and language. I think maybe my Korean partners will say a few words about that after my presentation. We'd like to try to conduct comparative research between the two countries, trying to understand what are the differences and similarities in the issues raised by a participant. It will be also to try to, by the discussion, to try to continue to improve this game. One important thing for me is to try to really have an open science mind and try to really transform this game of something which could be used by educators who are non-experts. So it means a lot of work on the rules, help to gather resource, also help to create a website which is really easy to understand. And we will also try to evaluate the effect. So I just have 2 slides more. I think I'm not too late. Is it okay? Yeah. So for my 2 last slides, I just want to take a step back and reflect a bit about first an important concept when working on algorithm, the concept of rationalization. If I take a look to my background in communication science and media education, concepts of representations and science have been central to the study of media and communication, especially, I would say, in Belgium, where we have a strong attachment to the field of semiology. These concepts are also central to media education, which tries to shed light on the sense-making process and the mediations at stake when we use, create, consume, interact with media, which are always a kind of a reconstruction of the world through science and representation. And I think it might be interesting to do a parallel and to reflect a bit on the concept of rationalization, which is another way, finally, to reconstruct and present the world. When you rationalize a digital world, you discretize the world into smaller computable units to create data, and then you apply computations, which may be stabilized and formalized into algorithm, to use, transform, manipulate this data in order to act and reach some goals, like recommending music videos to teenagers. In doing so, you pursue objectives and you depend on the resources you have to rationalize. And I think it might be interesting for media education to explore this idea that rationalization is another way to reconstruct the world, or to say it another way, another form of mediation. This might help to interrogate algorithm and rationalization process on many levels. And for example, I see 3 levels, but we should talk about that, and there are probably many more levels. A semiotic level, so many questions: how is the reality discretized, measured, ordered, and transformed into data? How is this data treated, transformed, visualized, presented? How does rationalization make sense? On the pragmatic levels, who are the developers? Where are the users? What are their intentions, interests, goals, constraints, resources, value when they are rationalizing? What are the actors of the rationalization? What are their relations? And finally, on a sociological level, who is able to program, understand, use digital media or not when rationalizing? What are the norms, the power relations, the value? So what is the society built by actors and collectives through rationalization? So those are some example of questions. And finally, I'd like to come back to a definition we've been working with since many years in Belgium. So this is a definition of a medium, given by Anderson in 1988. So this definition says that a medium is a human activity, that's important, which organizes reality in readable, action-oriented text. So as you said, text should be understood here broadly, not only as a written text, but as everything which might convey meaning and be interpreted. So I think it's one of the most interesting definitions of a medium for many reasons, because it puts the emphasis on the human activities related to media instead of on the technical object. because it stresses out the fact that a medium organizes the world and that it's a kind of reconstruction of the world and which also presents the world in a particular way. And finally, because in this definition, a medium is deeply connected to the capacity to share meaning and take action. And so if I think that's something we could discuss, but if we follow this definition, I would say that recommendation algorithms are media. And if we go back to the three axes, the axis one shows clearly that there are human activities because recommendation algorithms are computation defined and implemented by humans based on formalized operation on data sets and designed to produce classification. The axis 2 shows that they organize the reality and they try to rationalize it, and in our case, the question of the taste, which are a dynamical construct which emerge from the interaction between humans and the environment. And finally, axis 3 shows that recommendation algorithms convey sense. They may allow individuals to share meaning and also to take action depending on their intention, objective, and constraint. And finally, to say that algorithms are social construction and social constructor of taste. So that's it for my presentation. Thank you very much. And if you have any questions, thank you. Thank you. Merci beaucoup.
We are inviting Yeonju for another difficult and challenging intellectual work. Thank you.
자크 박사님께서 굉장히 많은 정보를 발표에다가 담아주셨어요. 그래서 제가 처음에는 필기를 열심히 하다가 어느 순간부터 이게 필기가 불가능한 상태가 되어가지고 오늘 발표하신 것도 나름 소화하고, 그리고 좀 오전부터 점심시간까지 만나면서 이 좀 프레젠테이션에 관해서 몇 가지 여쭤본 그 부분들이 있어서 사실 발표하신 것과 제 주석을 조금 섞어서 말씀을 드릴 수밖에 없는 상황입니다. 우선 그 자크 박사님은 나무르대학교, 벨기에 있는 나무르대학교에서 일을 하고 계시고요. 아까 처음에 정현선 교수님께서 설명을 해주셨던 것처럼 그 첫 발표를 어떻게 실천으로 옮기느냐, 그 구체적인 프로젝트를 지금 직접 수행을 하고 계십니다. 그 프로젝트의 이름은 영어로 하면 인더슈즈 오브 알고리즘이고요. 우리말로 하자면은 알고리즘의 신발 안에서 그냥 알고리즘적인 사고방식을 가져보자, 그런 의미로 해석을 하시면 될 것 같습니다. 자크 박사님께서는 좀 두 가지 학문적 배경을 가지고 계신데요. 하나는 커뮤니케이션 쪽이고요. 다른 하나는 이제 인포메이션 사이언스, 이 두 가지 관점을 가지고 이 프로젝트를 시작하게 되셨고요. 그리고 이 프로젝트에서 가장 관심을 가지고 있는 부분은 이제 미디어 리터러시, 그 미디어 교육 쪽에 가장 방점을 두고서 이 프로젝트를 진행을 하고 계십니다. 이 프로젝트에서 이제 하시고자 하는 바는 알고리즘이 우리 일상생활, 그리고 우리 사회, 그리고 우리 사회에 있는 제도들, 이런 것들에 어떠한 영향을 미치는지를 이 프로젝트를 통해서 특히 10대들이 이것들을 이해할 수 있게 돕고자 하는 것을 목적으로 가지고 있고, 단지 알고리즘뿐만 아니라 알고리즘과 관련된 이슈들을 10대들이 이해할 수 있도록 돕는 데 이 프로젝트의 목적을 가지고 있습니다. 온라인 홈페이지를 보여주셨는데요. 현재 진행 중이고 이제 조만간 영어로도 모든 정보가 나가게 될 테니 이제 프로젝트에 대해서 더 궁금해하신 분들은 아까 그 두 번째 페이지에서 보여주신 그 웹사이트를 보시면 될 것 같습니다. 프로젝트를 설명하기 위해서 무엇이 알고리즘인가 라고 먼저 질문을 던져주셨는데, 사실 많은 사람들이 이 정의에 대해서 잘 알지 못하고, 그리고 벨기에에서도 이거는 좀 약간 버즈워드, 그냥 유행하는 떠도는 말처럼 이렇게 사용이 되기도 합니다. 그래서 먼저 좀 알고리즘이 무엇인가에 대해서 정의를 내려야 될 텐데, 레코멘데이션 알고리즘이라는 그런 제목하에서 알고리즘을 세 가지로 정의를 해주셨습니다. 첫 번째, 알고리즘이라는 것은 어떤 개별 데이터를 매니퓰레이트하기 위해서 안정화되고 그리고 공식화된 절차들을 이용하는 것이기도 하고, 그리고 이용자와 어떤 객체들 사이에서 상호작용을 만들어내는 그런 것이기도 하며, 그리고 알고리즘은 어떻게 보면은 그 사람들로 하여금 어떤 뭐 기대라든지 아니면은 무서움 같은 거를 이렇게 만들어내는, 다양한 무서움이나 기대, 이런 감정들을 불러일으키는 와해적인 그런 영향을 주는 것이기도 합니다. 이렇게 우선 정의를 해주셨고요. 그리고 다음에 이제 박사님께서 주로 쓰시는 이론적 관점 이것들을 두 가지를 설명을 해주시는데 그 첫 번째는 미디어 에듀케이션 퍼스펙티브고요. 두 번째는 STS라고도 불리는 과학과 기술 연구에 관한 그런 퍼스펙티브인데 아까 개인적으로 대화를 나눴을 때 이제 얘기를 들어보면은 박사님께서는 좀 미디어 에듀케이션 관점을 더 많이 쓰고 계시고 요즘 읽고 계신 책들이 STS, 뭐 프랑스의 라뚜르 같은 학자들 아니면 시몬돈 같은 학자들이 좀 연구를 많이 한 STS 그 부분이라고 하십니다. 그래서 이 두 가지를 이론적인 배경으로 해서 프로젝트를 추진을 하고 계시고요. 이 인더슈즈 오브 알고리즘, 그러니까 알고리즘의 신발에서라는 프로젝트를 통해서 묻고자 하는 질문은 요즘 많은 디지털 미디어가 우리 추천 알고리즘, 유튜브나 이런 것들 보면 다 추천 알고리즘을 통해서 우리가 그 비디오를 맨 처음에 보게 되잖아요. 이런 추천 알고리즘에 의존을 하게 되는데 그 미디어 에듀케이션에서, 미디어 교육에서 좀 관심을 가져야 될 부분은 무엇인가 이러한 질문에서 이제 시작을 하게 되셨고요. 그래서 그 프로젝트의 방향성이랄까 아니면 접근 방식은 좀 실제로 이용자들이 맨날 그 유튜브를 방문하면서 접하게 되는 그런 문제점들이 있는데 이거를 실제로 경험하게끔 그 프로젝트에 녹여내려고 하셨다고 합니다. 그래서 게임을 개발하셨는데 그냥 펜하고 종이를 이용하는 게임이고요. 간단히 그 게임을 설명을 하자면은 그 학생들을 세 가지 그룹으로, 세 개의 그룹으로 우선 나눈 다음에 각각의 다른 데이터셋을 줍니다. 그 데이터셋에는 이제 다른 정보가 들어있는데 이제 어떤 정보는 뭐 각각의 유튜브 뮤직비디오가 몇 번이나 사람들에 의해서 사람들이 봤는지 아니면 몇 명이나 좋아요나 아니면은 싫어요를 눌렀는지 이러한 데이터셋도 있고 그리고 이 프로젝트를 만들 때 우선 두 명의 약간 페르소나를 그 실제 10대들의 기반을 둔 두 명의 페르소나 자넬과 니콜라스라는 이름을 가진 그 페르소나를 뒀는데 이들이 보는 뮤직비디오와 그리고 이 또래에 있는 다른 친구들이 보는 뮤직비디오가 얼마나 이제 다른 사람들이 공통된 뮤직비디오를 얼마나 봤는지 이런 데이터셋도 있고 그리고 다른 한 가지는 뭐 특정 연령대, 특정 젠더의 사람들이 특정 뮤직비디오를 얼마나 봤는지에 대한 데이터셋 이런 것들도 있어서 이렇게 세 가지를 우선 다른 팀들에게 각각 나누어주고 자넬과 니콜라스라는 이 가상의 인물들에게 10개의 비디오를 어떤 특정한 순서대로 나름의 계산식을 만들어내가지고 이 순서를 만들도록 이렇게 시키는 거고요. 그리고 각각의 세 그룹이 이렇게 나름의 순서를 만들어 오면 랭킹을 만들어 오면은 결국에는 그것을 비교하고 그리고 실제 니콜과 자넬과 니콜라스는 어떤 뮤직비디오를 선호를 했는지 실제 그 아이들이 좋아했던 그 랭킹과 비교를 해보고 결과적으로는 세 그룹이 함께 모여서 토론을 함으로써 어떻게 각각의 그룹이 무엇을 기준으로 해서 그 랭킹을 만들어냈는지 좀 공개된 토론을 하는 것까지 이어지는 그러한 프로젝트를 진행을 하고 계십니다. 그래서 그 각각의 게임 세션에서 있었던 아이들의 토론을 가지고 좀 세 가지 중요한 연구 결과를 보시게 되는데요. 그게 첫 번째는 데이터 앤 컴퓨테이션이라고 표현한 부분이시고요. 여기에서는 이제 아이들이 주로 얘기하는 것들은 데이터셋을 얼마나 다루기가 어려운지 그리고 특정한 그 계산식을 만들어내기 위해서 랭킹을 이렇게 만들어내기 위해서 이거를 공식화하고 이해하고 그리고 수행하는 작업이 얼마나 어려운지 그렇게 데이터와 그리고 계산에 관련된 이야기들을 아이들이 하고 그리고 두 번째로는 취향이라는 개념 그러니까 개인적인 수준에서도 그렇고 아니면은 좀 사회적인 수준에서도 그런데 그 취향이라는 게 언제나 되게 논리적이지 않고 시간에 따라서 바뀔 수도 있고 이제 이런 것들을 깨닫는 부분이 두 번째 결과이고 그리고 마지막으로 세 번째로 깨닫는 부분은 그 추천 알고리즘 그 자체에 관한 것 여기에서는 이제 다양한 수준의 어떠한 인터랙션들이 있게 되는데 개인적인 수준에서는 내가 좋아하지 않는 그런 뮤직비디오가 뭐 랭킹의 상위에 올라와 있어요. 되게 개인적인 수준으로 생각하는 경향도 있고, 그리고 좀 중간 수준의 그런 분석에서는 이게 뭐 아이들이 얘기하기로는 뭐 예컨대 좀 잘 나가는 유튜브 비디오만 좀 잘 보이게 한다든지, 아니면은 좀 다양성을 보여줄 수 있는 그런 비디오들은 좀 잘 안 보이게 된다든지, 유튜브 알고리즘 상에서 이렇게 좀 중간 단계의 논의를 하는 경우도 있고, 조금 더 넓은 사회적인 맥락에 있어서 그 레코멘데이션 알고리즘, 추천 알고리즘 자체가 어떻게 보면 사회적 구성물이고, 그리고 취향이라는 것을 만들어내는 역할을 한다, 이런 것까지 좀 얘기를 한다라고 세 가지로 이렇게 테마를 나누어 주셔서 설명을 해주셨습니다. 거기까지가 이제 프로젝트의 결과물을 보여주는 부분이고요. 그리고 마지막으로 강조하신 부분이 이러한 프로젝트를 통해서 그 미디엄, 우리가 뭐 미디어라고 부르죠? 이 미디엄이라고 부르는 것의 개념 정의를 좀 새롭게 하시는데, 이거를 가장 강조하시는 것 같은데, 그 우리가 좀 기술적인 관점에서 봤을 때는 뭐 TV라든지 아니면은 뭐 신문이라든지 이런 테크놀로지 기반의 미디엄, 그냥 문자나 아니면 심볼을 전달해주는 그런 미디엄을 많이 생각을 하는데, 근데 이제 박사님께서 말씀하시는 거는 단순히 미디엄이 그런 테크놀로지 기반이 아니라 그 실제를 구성하는 인간들의 행위로서 미디엄을 규정을 합니다. 그래서 이 프로젝트를 통해서 도출할 수 있는 그 미디엄에 대한 정의를 우선 사람들이 행동, 사람들이 실천, 행위여야 되며, 이것은 실제를 구성하는 것이고, 그리고 마지막으로는 좀 의미를 생성하고, 그리고 결국에는 사람들 간의 행위까지 도출해낸다. 이것이 미디엄의 개념이라고 정리를 하시면서 발표를 마무리를 해주셨습니다. 네, 이상입니다.